Let's start lecture 1. In this lecture, we are going to study thermogravimetry, also called TG. Firstly, we're going to study what it is, how it works, and what kind of things we can study. And I'll show you some examples, and also at the end we will have exercise. So the most important thing about TG, thermogravimetry, is it records changes in weight of the material subject to test. Usually under controlled temperature. Well, it says closed system. This is not exactly correct. Very often, measurement is conducted under gas flow, so it's not really a closed system. The analysis is very quantitative, and this is a technique very useful to study involves gas. Important thing to remember, however, is this is the information only related to the weight of sample. Therefore, it does not provide any chemical information directly. Let's have a look at how it works. Thermogravimetry, as I mentioned, is a technique to record the weight of sample. Therefore, it is essentially a very precise balance. Sometimes sample holder is hanging from the top, sometimes sample holder is supported from the bottom. One way or another, this equipment tries to record the sample weight, and chamber of sample holder is usually surrounded by heating elements, therefore it is possible to change the temperature. The balance is very sensitive, so up to a few micrograms it is possible to detect, and usually samples measured are in milligram order, so only small amount is required. In terms of temperature, measurement can be from room temperature to up to 1000, and some equipment allows you to study up to 1500. Heating rates is usually quite slow. In this case, it says 15 degrees Celsius per minute. This is about maximum people tend to use. 5 to 15 degrees Celsius is quite common. Sample holder materials, aluminum, platinum, silicon oxide, aluminum oxide. They are commonly used depending on the material and temperature. It is important to remember your sample and sample holder or flowing gas are not reacting. Sometimes on purposely you would like to have them reacted, but very often you would like to have your sample not reacting with sample holder or flowing gas. Therefore, it is impossible to know their compatibility before your measurement. So, what kind of things can we study using TG? Well, since this is a technique to record the weight of sample, any event related to weight change can be studied. Some of the examples are shown here. Absorption, adsorption, dehydration, vaporization, sometimes solid-solid reaction can be studied because they can generate gas as a result of reaction. Oxidation is also studied because it involves oxygen in atmosphere. So people tend to use this technique, TG, to study thermal stability of materials. This technique can be studied to kinetics of certain reactions, for example, oxidation or decomposition. These things are quite difficult to study, but it is possible to determine kinetics of reaction using TG. Corrosion study. This is also oxidation. This can be studied. Sometimes people use this technique to analyze the composition of material, purity of materials, because by heating material, they sometimes emit the impurity as a gas. Right. This is a typical example of TG data. This is calcium oxalate monohydrate. If you read any typical books explaining TG, this technique, this is the example people tend to use, because as you can see, it shows a very clear event at different temperatures. So as an example, it's a very good one. You can see, starting from original weight changes through 3 different events. Okay. So decrease in weight can be seen very clearly. This is typical way to identify the initial temperature and final temperature of a event. But this is a very ideal case. In reality, the data is not as clear as this, so sometimes it's very difficult to identify the initial and final temperatures of certain event. These temperatures can be affected by these factors. There are numbers of factors influencing these temperatures, so when you do measurements, you have to be aware of these things. Important ones are atmosphere. If flowing gas and the gas generated during this event are same or similar, then it has a significant impact on these temperatures. And also amount of sample and size, particle size. Very often samples are powdered, but particles of powders can influence again these temperatures. Heating rate and the material itself also. So usually, if you do not know much about your material, you might have to do measurement a few times to obtain a good data. Sometimes people tend to use another data in addition to this weight change. The data shown with lighter blue, it says DTG, is differential thermogravimetric curve. This is the first derivative of original weight change data. So this is showing the gradient. In this case, plus and minus are inversed, so the peak goes up, but usually this peak goes down. The good thing about this DTG curve is it is much easier to see the event. Well, since the original data is already quite clear, we may not see the benefit, but I will show you guys real data, so you will understand the benefit of this DTG curve. So this is one example of cementitious material we actually studied in our research. The TG data shows the weight decrease. However, Well, the events are not very clear. Maybe you can see a clear event here, or maybe here, perhaps here too. If we draw, in addition to this, DTG curve, it would look like this. Now you can see the quite broad event at the lower temperature and around 400 to 500 degrees Celsius, another distinctive event, and also around 600 to 800, another event. And also at the lower temperature, this is actually 3 different events overlapping together, or there are some small minor events also observed. So this is the big advantage of using DTG curve, first derivative of original weight change curve. Okay, so mainly it has a big one weight loss event, second event, and third event. This is another example. I have shown you guys this in the introduction. When cementitious sample is heated under different gas flow conditions. The first one, blue one, is nitrogen gas flow. In this condition, because the material was already hydrated, mixed with water and hardened cement, when it is heated, it starts losing weight because it starts losing water. Okay, so this is the typical behavior of cement. On the other hand, when measurement is in carbon dioxide, exact same material behaves quite significantly different. And weight at 450 towards 700, the weight even increases. This is because of the capture of carbon dioxide. Cement is quite interesting because it reacts with carbon dioxide and it captures. And based on these, it is possible to calculate in total how much carbon dioxide is captured by comparing these two data. Another important thing, as I mentioned initially, these data are purely based on weight change. It does not show us any actual chemical information. So what we usually do is combining this with different type of data, in this case, X-ray diffraction. So in this particular case, this original material heated up to 360, okay, and analyzed using X-ray diffraction and confirms the material contains calcium hydroxide. And this material is heated further up to about 660, and this data shows material is mainly composed of calcium carbonate. So calcium is capturing CO2. If the same material is heated further up to 800, the amount of amount of calcium carbonate decreases. So the weight loss here, we can understand this is because of the decomposition of calcium carbonate. So again, this is the advantage of combining this kind of data together with other types of data. So that's the first step of TG. Now it's your time to use your brain to try solving these questions. Okay, your exercise sheet has the data, so perhaps it's better to show that data. Let's have a look if I can show you guys this. Here you go. So this is the exercise. This is the data, same data shown in my lecture. And firstly, you have to try to estimate the weight loss event, this event, in milligram, when the original sample weight was 20 milligram. The key for event 1, 2, and 3 are shown here. So based on this reaction, you can tell why this weight loss is taking place. Okay, so try to estimate. You need to read this weight loss very carefully, and please try to solve this question. And question two is asking, once you know how much of these events are taking place, I'd like you guys to compare which event is taking place more. Perhaps you can compare these events in terms of moles. Please try, and answer will be explained in the following lecture. Good luck.